Hello everyone, I am Aditi Kumar and welcome to another session related to perceptron. So perceptron is a fundamental concept, or I can say the foundations of artificial neural network that we discussed in our last video. So today we will discuss about how we can implement the different architectures or maybe some basic artificial neural network architectures using this perceptron. Let's start for today. So specially today we will focus on basically the single layer perceptron, because this is basically the fundamental architecture and we can only implement specific logical gates using single layer perceptron. Some of the specific, or maybe I can say another group of logical gates, we cannot make it using single layer perceptron. In that case we need multi-layer perceptron. I will explain actually why it is like this, but today specially we will focus what are the gates, what are the logical gates I can say we can implement using single layer perceptron architecture. Let's start for today. Okay, so using single layer neural network we can only implement three logical gates. One is AND gate, OR gate and NOT gate, and I can say the implementing these logical gates is a fundamental or maybe a classic example of implementing artificial neural network into action. Why basically we can only implement AND gate, OR gate and a NOT gate using the single layer perceptron or single layer neural network? Because whatever the input space, input combination means input space we are having in case of these three gates, we can separate using a straight line or maybe a linear separable input space. I can say whatever the input space or combination of inputs for these three gates, we can easily separate using a linear plane. In our last session we discussed actually single perceptron is always applicable to easily separate two categories. Linearly separable, the groups are linearly separable. There is not any non-linearity maybe behind the separation. That's why we can only implement AND gate, OR gate and NOT gate using the single layer neural network or single layer perceptron. Let's start one by one. So if I am talking about AND gate, always basically AND gate having I have taken the example here, two input and definitely one bias, and we will have a output. And again there is a certain equation is written here, w1 x1 plus w2 x2 plus b less than equal to 0. So this is basically represents the decision boundary. So decision boundary means it's basically the boundary which can separate these two groups, two classes, because here I can say our output is 2, that means 0 or 1, either positive or maybe 0, high or low, like that. Signal point of view, it's high and low, right? So whatever the input space we are having for AND gate, we can separate using this that particular equation, that particular decision boundary. Here W1, W2 is a W1, W2 are weights, B is bias and x1, x2 are the input. Let's discuss more on geometrically. So if I am taking here x1, x2 and here maybe output is y, so your 0 0 combination is 0 1 1 0 1 1. But in case of AND gate, only when the inputs are 1 1 we can get 1, right? So if I will represent geometrically, here this is x1, this is x2 here it's 0 0, here basically it's I can say 1 0, this is 0 1, and this is 1 1, right? So here for 1 1 it's output is 1, and here 0 0 0, and here the input planes easily we can separate using a linear boundary. This is the decision boundary. This is the decision boundary. For a certain value of W1 W2, we can achieve this. If I will implement using architecture point of view, here this is actually our summation. Here maybe I can say our neuron, our perceptron. Here basically x1, here x2, here W1, here W2, here B, and we are getting actually x1 W1 plus x2 W2 plus B. Then we are basically passing through a sigmoid function. Then sigmoid function actually giving a I can say separable. Actually based on that, actually it will basically decide what it will be either 1 or 0 based on certain threshold, because there is a certain equation based on that it will define actually whether it will be, because that threshold actually we need to provide. And again finally I can say this is a one classifier, actually it will contain, finally it will give the output. This is the sigmoid function. This is basically the architecture of we can implement using a single layer. Your sigmoid and your sum, or here maybe I can say the summation, the order, which basically artificial neural network. This is basically the specific to your AND gate. If I am talking about OR gate, the similar way, the decision boundary equation is W1 x1 plus W2 x2 plus B greater than 0. So if you will basically implement geometrically, I can say let's here it's x1, here x2, here maybe I can say some y hat is your output for this particular gate. Here 0 0 0 1 1 0 1 1. So here you will get 1 here and 0. If you will basically put it geometrically, so x1, here x2, so here 0 0, here 1 0, here 0 1 and 1 1. For 1 1 always basically you are getting a 0 and you are getting 0, so you can have this type of boundary. This is your boundary equation. If you will implement in neural network, so maybe your x1, your x2, your W1, your W2, this is your B, and you will basically pass through a sigmoid function, then finally you will pass through a classifier and you will get output. This is your OR gate, and this two part is basically your artificial neural network. So this is basically the implementation perspective. And the last gate here is NOT gate. So the boundary equation is like this: Wx plus b less than equal to 0. So I can say implementation perspective, it's basically one input and one output. I can say it is basically the complement. Then 1, it's 0. It is basically in geometrically, this is a one plane. One plane I can say on other plane, this is a point which can separate maybe 0 and 1 value. This is a point geometrically. And the implementation perspective, same, maybe here it's B, here it's x1, x maybe it's W, and I can say we will pass through again it is basically a it's either it is a 0 or 1. It's based on that, and we need to pass through a sigmoid function, or then maybe one classifier. It will basically provide the output. whether it is 0 or 1. The possibility is 2, right? When we are giving 0, we are getting 1, where we are giving 1, we are getting 0. This is basically the implementation of AND gate, OR gate and NOT gate using one layer neural network, or maybe one layer artificial neural network or perceptron. Let's summarize these three. So if I am talking about perceptron, it's basically one layer. We discussed actually in our last session, multi-layer. So here, example point of view, we implemented OR gate, AND gate and NOT gate. Here we can implement maybe NAND gate, NOR gate. These are the basically examples we can implement. And here this is only one layer of perceptron. Here multi-layer of perceptrons. Here maybe one, I can say one, or maybe for this particular example it is one neuron only, one neuron, but multiple neuron can be possible here. Here multiple neuron definitely. Here either or one or multiple. But if you are taking basically some different example, which can be possible using one layer of neuron. So in that case, basically multiple neuron can be applicable in a single layer. But again, definitely I can say, but most of the cases I can say it's basically one neuron only. But in case of multi-layer, so definitely we need actually multiple neurons to implement this particular thing. So this is basically the beauty of artificial neural network, and how we are implementing using basically the concept of perceptron. So before starting basically directly some modeling from any data set, so I thought I will start with some conceptual thing, how, because your interesting point is how we can define or maybe architect artificial neural network. We cannot basically, you should not always directly copy some code or maybe some idea from any internet or thing, right? So we need to build we need to understand our problem statement, we need to build our architecture such a way that so we are understanding everything, and basically we are maybe I can say aligned with our business, and we understand everything, and we are putting the correct architecture in place, so that our definitely we will have a robust architecture and implementation perspective with a good accuracy. Thank you very much for watching this particular video, and please do subscribe my channel and put the comment under this particular video, so that it will be really helpful for me to prepare further videos related to deep learning and neural network. Thank you once again for watching this particular video.